Hello. In this video, we are going to talk about integration by parts. I'm going to introduce it from scratch. And I will go through some examples and some alternative methods for doing it. And it'll probably take multiple videos to get through all that stuff. Before I ask you to do these 4 problems right here, I just want to say that of all of the BC Calculus curriculum, I think that integration by parts is probably the most important piece of it. It is the piece that shows up the most and becomes the most essential as we move on to the next levels of calculus, at least in my opinion. Not everyone's going to agree with me. Um, so I have this formula with U's and V's. That is actually the formula for integration by parts. I'm going to show you where it comes from in a moment. And then I just want to point out that there is something called tabular method, and I'll teach that to you. But tabular method is typically the way that I like to do integration by parts. So now we're ready for you to do some stuff. I have 3 integrals and a derivative that I would like you to calculate. So go ahead and hit pause and do those 4 problems, and I will pop the answers up and go through them in a moment. So hit pause. Here come your solutions. Okay, answers here are boxed. I suspect that the most common error for the first 3 would be to have the same thing that I have, but negatives. When we get into integration, everyone always flips up which ones are negative. The integral of cosine is a positive sine x plus a constant. Why is that? Because sine, a positive sine, derives sine prime of x as cosine. So the integral is going to be the opposite of that. A positive cosine integrates to a positive sine. If I wanted to do the integral of sine x dx, that's the one that gives me a negative cosine x plus a constant. And that's important to, not mess up as we move forward because there's going to be lots of sines and cosines in our integration. All right, so the next one, little bit of u sub. I get 1/2 sine of x squared. Okay, sweet. And then the next one also, a little bit of u sub, kind of the same idea, except for I've got cubed. So I wind up getting 1/3 sine of x cubed plus c. And then the last one sort of seems unrelated right now because it's a derivative. But the key here is that I want you to see, oh yeah, I remember product rule. So hopefully you remembered product rule correctly and you got this one right. So I am going to take this one right here. This one was doable because I could calculate that integral. You could calculate that integral because we had the u sub, right? This x matched that x squared. So what happens if I rewrite that problem, but I get rid of a piece? I get, whoops, not 2 pieces. Whoops. Whoa. All right, just that piece. So what happens if instead of the integral of x cosine of x squared, which is set up for me to do u sub with, I have the integral of x cosine x. You should see that I can't do u sub. It just doesn't work. So this is the kind of classic entry point problem for what we need integration by parts for. This formula here looks totally foreign, and it probably doesn't make any sense when you look at it. But that formula is going to help me to do this integral. It's also going to help me do so many other things in the future. So what I'm going to do is work out why this formula has to be true, and then we're going to go ahead and we're going to use it to calculate what this integral is going to be. And we'll see if that'll even fit into this video. It's gonna take some time to get all that stuff, but I want you to fully understand where the formula comes from and how to do the formula and how to connect it to what we call tabular method. So let's start with working out this formula. The reason I had you do this problem is because this formula is just really an alternative to product rule. So I'm going to try and make sure that my U's and my V's do not look similar. But say I wanted to do the derivative, up here actually, I said the derivative of the derivative of this with respect to x. So I'm just going to say, let's do the derivative of u times v. Normally, I would write that as u times v. Actually, I guess I'll write it here. Normally, I would write that as u times v prime. And we would write it as u prime v plus v prime u. The derivative of u, or the derivative of u here, the derivative of v here. Derivative first times the second plus the second times the fourth. You should be okay with the product rule. Instead of using prime notations, though, what I'm going to do is do this derivative and, represent it as d just saying take the derivative, right? And I'm not really defining what I'm deriving with respect to, just whatever variables we have there. So if I do that, I get the derivative of u times v plus the derivative of v times u. You should see that this is just the same, these two lines say the same thing, just with a little bit different notation. So let me change this around a little bit. I'm going to write this as the derivative of u times v equals, and then I'm going to write v times the derivative of u plus u times the derivative of v. All I did was flip the order of those. Now what we're going to do is integrate both sides, okay? And remember, my goal is to get this formula right here. So what do I get? I get the integral of the derivative. Remember, I'm just kind of like being arbitrary about what we're integrating or deriving with respect to, because it's just whatever variable we have. It's cool. So when I integrate the derivative right here, I just get u times v. And then over here, I'm going to just leave those as is. Integral of v du plus the integral of u dv. And notice I almost have my formula up here. So all I have to do is take this term here and subtract it and move it over to the other side. And that gives me, like, basically I'm solving for this. And if I solve for this and write it first, integral of u dv, that is going to be equal to this guy, which is u times v, minus this one, which is the integral of v du. And that's the formula for integration by parts. It's not, you should see that it is really just another way of writing the product rule. And once you really, really get to understand integration by parts, you'll see when you use it, you are just undoing product rule. But for now, we got a formula. So let's go ahead and use it. I'm going to use it to do this integral, and I think you'll see that it solves our problem that we have with this one, which is that we don't have the u sub. So I got the integral of x cosine x dx. Whoops, not du, dx. All right, I am going to highlight some things for you. So my x, and for now, just kind of follow along. Don't worry about like, wait, how did you decide what was what? Because you will see that and you will learn it and you will understand it as we move along. So x is going to be my u. And cosine x dx is going to be my dv. So let's write that. U equals cosine of x. And I'm going to write over here dv equals, oh no, come on. U is not cosine x, silly. U is x and dv is cosine x dx. From here, notice this formula says u times v. So this integral is going to be equal to, all right, u times v. Oh, I got my u. It's x. I need to find the v. So in order to find the v, I've got this right here. It's like separation of variables already set up for me. So what do? I'm going to integrate both sides. So let me do it in a different color. I'm going to integrate this and this to get that v is equal to, all right, the integral of cosine x dx. Remember, we just did it. It's up here, cosine x dx. That's sine x. And I'm going to write sine x. I'm not going to write the plus c. Maybe I will explain it later. It has to do with the fact that I'm calculating one integral, and I'm writing this, and then this is another integral over here, and this integral over here is going to have a plus c anyway, so I don't need to have a plus c. It's just going to appear with this piece. Maybe that made some sense. All right, so let's go through. All right, I have my u, I have my v. Let's make those look like check marks. I've got that piece, I've got that piece. Oh, and I've got v, right? Because I'm going to use that in my formula there. So, but now I need to do the integral of v du. So I need to find du. So what I'm going to do here is I'm going to d both sides. I'm going to find the derivative, right? And what does that give me? That gives me that du equals dx. So let's fill in what we have. I am going to try to highlight some things so we can make sense of all these pieces. All right, so I've got, oops, I'm not going to use that color. Let me use purple. I've got u because it matches this one, and that's this. Okay, so next, v. I've got v. All right, v is this, which is sine x. So I'm going to write times sine x minus the integral. Oh, and look, I've got v here again. And this seems like complicated, but don't worry. I'll give you good, easy ways to do this. So I've got my v right here. And then highlight this. Oh, gosh, I'm jacking this up. Now it should be good. Sine x, those are my v's. And now I need to put my du in there. And notice here, du is dx, right? So let's get a new color there. Du is this, du. So I'm going to put a, whoops, dx there. And that is this yellow piece right here. So I hope you see all these different color pieces right here. So now I'm just going to kind of write this without all the colors. I got x sine x minus the integral of sine x dx. So we can do the integral of sine x dx. The integral of sine x is a negative cosine x plus a constant, right? So this gives me x sine x minus, and then sine integrates to a negative cosine x plus a c. Notice I got my plus c here doing this integral. That's what I was trying to say earlier over here. And then I get x sine x plus cosine x plus a constant. What I want you to see, I kind of posed this problem originally as we don't have the u sub for it. Like this x is what's messing things up, or the fact that I don't have the right piece in here. But look what this did. What it did was I turned this integral into x sine x minus another integral. And this second integral here was something for which that x is gone. It now only has a sine x. So it kind of got rid of it got rid of this issue and gave me something that was integratable. And that is fundamentally what integration by parts does. It takes something that is in the way and it gets rid of it. And it does it by taking the derivative. And I'll show you some more ways in the next video.